Okay. Let me start. As you know, there are many ways to stabilize an urban slope. The common methods that you are familiar with are the reinforced concrete wall, or power walls, or cable walls. So you see these everywhere. The concrete walls, very common behind bus stops. The power walls, very common when you go down the basement car parks. And the gable walls along the ABC cycling tracks. However, in these systems, there is a lack of greenery, and they are mostly made out of concrete, which is carbon intensive. So this carbon intensive contributes to the urban heat island effect, which has been heavily discussed in this year's Urban Sustainability R&D Congress, where they said that built-up areas can be up to 7 degrees warmer than rural areas. So this brings us to the effort to try to green up as many concrete places as possible. With that, I would like to introduce geosynthetic options of greening up a slope. Commonly used in Singapore is the geowebs. So LTA uses them for the slopes beside the expressways. However, the geowebs are mostly limited to grasses and shrubs and ground covers. The problem with these simple geosynthetic systems is that it's usually limited to 45 to 60 degrees, and it's not near vertical like concrete structures. So most development project teams have this problem. They usually push it to the side as a green buffer, or it's restricted to lower heights. Of course, there are more complex geosynthetic systems that allow more than 60 degrees, such as GeoGrid with tieback. And today I'll also be introducing one such complex geosynthetic system. This is one such geosynthetic system. It's the GeoBarrier system, and it's a system that my company has invested in. We hope that you will be interested in this technology as well, and we hope to share more in the next few slides. So those tendering for HDB contracts, especially in Bidadari and Woodlands, we have noticed technical specifications inside for the construction of the GeoBarrier system. Okay, so take a look at this GeoBarrier system on the left. Don't you think it looks better than the concrete wall on the right? I know all the pros are talking about concrete, but this is so it's large greenery combined with innovation and sustainable geotechnical engineering that's applied in everyday life. So we feel that this is a new and innovative way to stabilize a slope in the urban setting. Allow me to go through 3 key features of this system, jointly developed by NTU and HDB, catered to 3 distinct groups of people in the crowd today. So the first key feature that will interest the green mark managers in the room, I'm going to talk about the sustainability of this product. It uses fine-grained recycled concrete aggregate and coarse-grained recycled concrete aggregate, and these are found in construction debris, which is readily available whenever there are demolition projects around. If you see this part of a site elevation, a little bit technical, but the fine RCA is a layer in pink, and the coarse RCA is a layer in blue, and behind that is a layer of compacted salt. So these recycled materials make up more than 70% of the system. So it's quite cost effective and it's sustainable. Okay, the second feature will interest the consultants that are doing ST submissions. A few studies conducted in the GeoBarrier system, this one, reviewed that the factor of safety when plotted over time, so this factor of safety and this is time, this is a normal slope that's not protected by the GeoBarrier system. You can see that there's fluctuations in the factor of safety, whereas the red, black, and the blue lines are the ones protected by the GeoBarrier system. So you can see in this trial there's a slope 1, slope 2, and slope 3. Of course, there's a control slope somewhere here, that's not featured. Basically during rainfall, you can see that the factor of safety deviates, especially just after the rain. Okay, there's another section with regards to the code of practice for surface water drainage, where you are required to calculate the Q. So we are in the process of calculating this C, but right now it's less than 0.55. For more details, you can refer to this monograph, which I will elaborate on later. Okay, the third feature will interest the landscape architects and landscape designers. So up to 16 species of plants have been test bedded on the GeoBarrier system, and more are to be tested in upcoming projects. The key feature that differentiates the GeoBarrier system from other kinds of GeoBag systems is that we have this thing called the custom planting pockets. So the planting pockets are actually reinforced with the geofabric, which means that when you plant bigger species plants such as the Monstera, the one at the bottom, you are able to fit it in, and the landscape architects can design the slope as per their creativity or imagination. Okay, it's interesting to note that how the roots developed the system over a 12-month period, because when we took apart the bags, you can see that on the picture on the left, the roots actually weave out of the bag and into the adjacent bag. So you can tell over time the system becomes more and more robust, and it's more and more stable. This special fabric is developed by Tank Carter Geosynthetics. I think some of the key items that really stand out are high tensile strength and high UV resistance, which is pretty normal, but it's also highly permeable to allow water and roots to travel in and around and within the system. Okay, so how does this GeoBarrier system work? Developed by NTU and HTB under Prof. Haryanto's guidance. The GeoBarrier system is an earth-retaining structure and slope stabilization system against rainfall-induced slope failures. So this system elegantly applies unsaturated soil mechanics using volumetric water content, permeability of sand and gravel, and metric suction principles to create a capillary barrier effect. Okay, if you see this illustration, the blue arrows are signify rainfall or water. It enters the top of the system, it flows down the fine RCA layer and into the drainage. And all this time, it does not enter the coarse grain layer behind. So this is the most interesting part of this system, because by using these recycled materials, we actually create a drainage layer that stops the water from infiltrating the slope. It's basically quite counterintuitive because of the permeability of fine grain and coarse grain under unsaturated soil conditions. We feel that this system is more superior than other geosynthetic systems out there because most of them are required to install a geodrain layer behind to capture the water. And it's this idea that has prompted our company to invest heavily in this technology. So Polymer Engineering has been involved in GBS development since 2013. We were engaged as a contractor to build a capillary barrier system in Lorong Halus. Since then, we've been involved throughout the years in technical specifications, to testing requirements, to instrumentation and monitoring, and design of the GeoBarrier system. In 2018, we were awarded a GovBack with HTB for the improvement to GeoBarrier system, which I will elaborate more later. So why did we choose to invest in the GBS? Well, why not? We feel that it's the future of slope construction, and we have to invest in future technologies to stay relevant. I have a strong belief in geosynthetics' potential to replace reinforced concrete structures. In many overseas countries, there is wide-scale adoption of geosynthetics for slope protection. I also believe that engineering calculations for slopes should adopt unsaturated soil mechanics. Currently, the BCA submissions are based on the assumption that the slope is really saturated. I think this assumption artificially inflates the factor of safety and leads to over-design. And for the developers, it increases the overall construction cost of the slope stabilization unnecessarily. So we feel that this solution can be a cost-effective alternative to other slope solutions out there. So if there are some BCA colleagues out in the crowd, maybe you can consider this. Another opportunity for us is that by analyzing the problem from a design thinking approach, POCLIM's own engineering team continues to improve in their skill set and knowledge, and it shows when our team carries out civil engineering works confidently out in the field. Another reason is the opportunity to work closely with HTB and NTU. We were awarded the Cool Ideas Enterprise Award last year. Over here. Very good. This grants the company an edge in tendering for more government projects. Also, this technology offers opportunities for our regional expansion program. The other benefits that we have is that Tenkata has supported us by granting us a distributorship for the GeoTube geobags, and Enterprise Singapore has supported us by giving us a grant to improve on the GPS. So we aim to impress all our stakeholders who have invested their time and money in us. Our ambition is to be a turnkey market leader in GPS, to design, submit and endorse, to supply and deliver pre-filled and pre-compacted geobags, to install the GBS, to test the GBS, and to carry out instrumentation and monitoring works for the geobarrier system. As part of the grant, we commit to develop in-house R&D capabilities for continual improvement for future collaborations, and to develop a best practice guide on the design and construction of GPS. By the way, as part of our expansion program, we are always on the lookout for talented and passionate people to join our team. So if you are a civil engineer, you've got an interest in geotechnical solutions, and you have a strength in your instrumentation and monitoring, please come and look us up. Yeah, after the talk. Okay, I'm coming to the end of my presentation. Hocklim is riding on the government's vision for greening up of previous concrete spaces, such as the development of ABC projects, vertical gardens, and rooftop gardens. Now, GBS has been applied to underground car parks in HDBs estates as a greening and slope retention option for a wall-free multi-level basement car park. So as compared to an underground car park, this is an option where it's naturally ventilated. It allows light to come into the car park and can provide green replacement within the development. We are constantly exploring more ways to apply the geobarrier system into developments. So if you have any ideas, government agencies such as JTC, PCA, TUB, please feel free to approach Mr. Benny Neo, my GBS development manager, for more information. Okay, lastly, I'd like to thank the following groups for allowing me to speak today. From NTU, Dr. Richard Hung, Prof. Haryanto and Dr. Alfredo. From Building and Research Institute, Mr. Wang, Janice, Vincent, Wan Bian, Teo Hong, and Angelina. From Enterprise Singapore, Ting Zi, Yao, Sally, and Mok, I forgot the your name, sorry. And Tenkata, Albert, and Siu, and also the Hocklim GBS team. Thank you.
Some questions. How different is the GBS from vertical green wall?
Okay, so the vertical green wall is not a slope retention system. The vertical green wall is a green replacement alternative. In that sense, actually the geobarrier system is commonly mistaken for a landscaping kind of, and in fact, I think HDB put the technical spec under the landscape portion. So when they pass it to the landscape contractor, they're like, oh, they do not do it. Yeah. So my own personal opinion, I think it should be in the CNS side because it's a little bit structured. Yeah.
So earlier you showed the GBS system that is used on basement car parks.
Yes.
So the question is, will the drainage be challenging in this case?
In fact, actually, it's already constructed in the HDB estate, but then my slides cannot clear HDB, so they said, please remove all the photographs. I will do with it. The drainage, we're using back the same drainage from the car park. So the important part about the system is that because of we are able to modify the runoff coefficient, and it's lower, so the slope actually retains some water as compared to say RC wall, for example. The drainage, actually there's two layers of drainage. Can I go back up there? Oh, this is my chance to be technical. Wait, let me see. Okay, so you see a drainage layer here. This is the one that comes out. But underneath, there's actually a gravel layer. So this gravel also conducts water out, and this gravel goes to another sump. It's interesting that the drainage layer actually is underneath the system. So you don't actually have to cater extra space for that. Yeah.
Okay, one last question. How often the maintenance is required for such a GBS system? For the
Okay.
plants?
Oh, okay, so when maintenance, there's two main areas to consider. I think the first one is the CNS portion. So for CNS portion, the beauty of this system is that the geosynthetic fabric is really very and durable, and mostly for geosynthetic systems because there is woven and non-woven fabric, and most fabrics they have very low UV resistance. So the product that we took from, rather Tenkata has developed, is used extensively for marine applications, such as the Tekong project and stuff like that, where they have geotubes for land replication. So we adopted, or rather they adopted this technology into this system. So I think that part of maintenance, no problem, because for land reclamation it's pretty permanent. On the plants part, when you have custom planting pockets, actually it's just as easy as potted plants. Yeah, because you take the root ball out and then you place it with the plants. So I think from the landscaper's point of view, it's quite a clean way of doing construction. Other systems actually require you to cut more holes in the decks to take out the plant fully. But because of these pockets, we managed to circumvent this problem.
Thank you very much.
Thank you so much.